What is the core component? Core component is TCP/IP protocol. I have already discussed that all the internet basically are using, the internet is using this technology, particularly TCP/IP technology, or TCP/IP is the name of protocol suite, which is not the name of a single protocol, but certain protocols are there on various levels, and they are supporting various kinds of tasks which are being performed in the internet while transmitting the message from one place to another place. We will see another protocols such as HTTP, DNS, other application level protocols which supports various applications to run on the internet. So these internet technology facilitates reliable, secure and efficient communication across diverse networks and devices. So first of all, we will see about internet protocol. What do we mean by internet protocol? So internet protocol are set of rules and conventions that define how data is transmitted and received over network amongst various components which is part of the network. The purpose of having internet protocol is standardization. It ensures compatibility between different devices and networks. It optimizes data transmission and minimizes delay, while it provides guidelines for secure data exchange among various devices of the internet. It is essential for all forms of communication over the internet, from browsing to email or streaming. To streaming. So it supports various kinds of applications to run on the internet. We will have a brief overview of TCP/IP protocol suite. So TCP/IP is the fundamental suite of communication protocol used to connect devices over the internet. This is the main protocol I mean to say. Main component or main protocols of the TCP/IP, as the name suggests, is that TCP is one protocol and IP is another protocol. So these are the main two protocols. Apart from that, there are several other protocols which makes the complete suite, but these are two main components of TCP/IP. TCP stands for Transmission Control Protocol. It ensures a reliable, ordered delivery of the data packets, and IP manages the addressing and routing of the packets across the network. It allows the packet to move from source to destination node. So these are the backbone of internet communication, enabling data transfer across various types of network. Here you see there are basically two models. One is known as OSI model, Open System Interconnection model. Another is known as TCP/IP model. So OSI model, which you can see over here, that is a theoretical model basically. So whenever it is designed to have a network protocol, whenever anybody or network programmer wants to design a protocol, they must take care of these kinds of applications. So physical layer applications, data link layer application, network. So in a network basically several kinds of tasks are there, and these tasks has been modularized, and each module is known as over here layer. So some things which is done by the physical layer is known as physical layer protocol. Another tasks which are done by the upper layer is known as data link layer protocol. Another task has been grouped under the network layer, and they are known as network layer protocol. Another kinds of tasks, they are combined over here, they are known as transport level protocol, session layer protocol, presentation and application layer protocol. So in all there are 7 layers over here in case of OSI model. So these are simply the guidelines or the reference model basically. So whenever anybody wants to develop such kind of protocols, they must follow these reference model. But here this is the actual model, which is the working model basically known as TCP/IP, and here we do have basically 4 layer of protocol. You see here link layer, where data link and physical layer activities has been combined in one layer, that is known as link layer protocol. Network layer protocol has been called here internet protocol. So all the tasks which are performed by network layer, that is performed by internet layer in TCP/IP. Another layer protocol is known as transport layer protocol in TCP, and above that we do have application layer protocols. So here effectively we do have 4 layers in TCP/IP, and this is the actual model, this is the working model, and we do have certain protocols corresponding to matching to every layer. Say for example here for link layer we do have Ethernet protocol, token ring protocol, frame relay, ATM relay. Similarly, related to internet layer we do have ARP protocol, which I have already discussed in my previous session, IGMP protocol, ICMP protocol and IP protocol. Similarly, related to transport layer, we do have two main protocols are there known as TCP protocol and UDP protocol. And on the application layer, we do have a bunch of protocol which supports various kinds of applications. HTTP protocol, all of us know that whenever we search some information on the Google or on the search engine, your search request goes to certain server, and that server collects the information for you and pushes back the information or search result back to your computer, and you can search all these computers one by one. That happens with the help of HTTP. So all the browsing related tasks are supported by hypertext transmission protocol. FTP, file transfer protocol, is another protocol. If sitting at your own computer, you want to transmit some file to a computer which is kept far apart from you, say for example in any lab of US, and you do have the login and password of that computer, sitting at your own computer, you can transmit the data to that server, and even from that server, you can transmit or you can transfer some files from that server back to your computer. But for that, you need certain application program protocol, so that is known as FTP, file transfer protocol. Similarly, for sending the emails, basically, we do have SMTP protocol. So for different kinds of application, we have different supporting protocols. They make it possible to happen, to work that particular application. So email, simple mail transfer protocol is there, and this supports the mailing activity. So if anybody wants to transmit a mail from one computer to another computer, they can use SMTP protocols for receiving the mails. Similarly, DNS application, domain name system, is there. I have already discussed in my previous sessions that there are two ways of addressing. One is IP addressing, which is the number based addressing. Another is basically name based addressing, generic name based, say for the google.com. So for us human being, it is easier to remember google.com instead to remember the IP address of that Google server. Fine, but the practical situation is that, but in actual, the message is transmitted not through the google.com, but through IP address of that server. So all the routers, whenever they transmit the information from one place to another place in the network, they are being done with the help of what? With the help of IP address. But you are using google.com. So how the corresponding to google.com from generic name to IP address conversion is required, and that is done by DNS, domain name system. Another is RIP, routing information protocol. So for transmitting the message within the autonomous system, we do have RIP protocol. Similarly, SNMP protocol is there for network management. We do have simple network management protocol. For managing the activities of network, we do have this kind of protocols. So in that sense, I am telling you that they are known as protocol suite. TCP protocol suite, because it is not name of a single protocol. It is a collection of various protocols which supports various kinds of activities, and these activities are in the layered form basically. This is layer 1 activity, 2 activity, 3 activity, and like that. Fine. So OSI model, what is OSI model? It is a theoretical model with 7 layers over here, and TCP IP model is a practical model with 4 layers. So all the implementations are based on the TCP IP model. If you like to have a comparison between these two models, a comparison can be done by seeing these two figures. So both models serve similar functions, but OSI is more detailed while TCPI is more practical and widely used. OSI is used for conceptual understanding, for reference model, while TCP is used for actual implementation. Understanding both the models helps in troubleshooting network issues and understanding of protocol behaviors, and while anybody wants to develop this kind of protocol, they are of great help. So we will start our discussion from the protocols of the application layer protocols. So we will see very briefly these protocols, then we will come to this level protocol, then come to this level protocol, and like that. So we will start from the application layer protocol and go. You might have seen that many times we use google.com, hotmail.com, rediffmail.com, or gov.in, like that. So they are basically known as, they are the addressing system. Using this, we can identify various sites or various servers basically. They are known as domain name system. But in practice, in reality, whenever the computers are communicating with each other, they don't recognize these DNS name, google.com or rediffmail.com or hotmail.com, or say for example gov.in. These kind of things are not understandable by the computer. They only understand internet addresses basically, and IP, which is known as IP addresses, and IP addresses are a numeric form, are in the numeric form. Then your question will be then how they communicate with each other. So okay, for human being it is easier to remember these domain names, google.com, maybe hotmail.com, rediffmail.com. It is easier for us to remember compared to address of the IP address of the Google server, which is like that 192.10.111.254 and like that. So this kind of 32-bit, I mean to say in 4 digital or 4 decimal octets or 32 bits number is there, which is the format of IP address. It is difficult for human being to remember. So instead of IP addresses, we use DNS basically, domain name systems, or these domain names. But whenever the computer wants to communicate, so for example, we give that google.com. So immediately it goes to a server where it finds the mapping corresponding to Google map, mapping to an IP address. So what is the corresponding IP address to google.com? And then after finding that, then the actual transmissions starts. Then the actual transmissions, or say the activity starts from their place. But how these things work, how the resolutions from name, domain name to IP address occurs, all these things are discussed under this category, what is known as domain name system. So domain name system translates human-friendly domain names like google.com, rediffmail.com into IP addresses that computer uses to communicate. How does DNS work? DNS resolution. I have already told you that before any communication takes place, the domain name resolution takes place. Resolution means corresponding to domain name, IP addresses is found, and once IP address is found, then the request is sent to that particular server using this IP address or using the TCP/IP protocol. So the process of converting a domain name into an IP address is known as DNS resolution. How does it happen? So root servers are there, direct request to top level domain server. TLD servers are there, which stores information about domain name with specific extensions, and authoritative name servers provide the actual IP address for requested domain. So these are several mechanisms using which DNS RAM resolutions takes place. It is essential for web browsing, email, and for all internet services relying on domain names. So whenever you are using any domain name, and in most of applications you are using the domain name. Hardly we are using IP addresses 192.10.11.253 like that. I am not using this kind of addresses in our common or even daily life applications basically. So these domain name applications are, domain name systems are vital for transferring or for translating our domain name to the corresponding IP addresses. Another very important application is there, which is known as FTP. So FTP is a standard network protocol used to transfer file between a client and server over the TCP based network. I have already told you. So it's a remote server. If you want to transmit some file from your computer to that computer or from that server to your computer, that will be done with the help of file transfer protocol. So it is a client server architecture. Your computer will be known as the client, and the computer which is providing you the services will be known as a server. So FTP, client request files from FTP server, and FTP server will pass on that file to the requested client. Active and passive modes for different network setups are there. So various kinds of setting or configuration for the FTP protocols are there. So plain FTP is insecure, while secure version like FTPS and SFTP provide encryptions basically. I have already told you in my previous discussion that while the files or the data is being transmitted, anybody can intercept the data while it is in transit basically. And it is very vulnerable, I mean to say, to attack or for the hackers. So to have a more secure transmission, you have FTPS, means secure, or secure FTP to provide which transmits the data in encrypted form, so that if anybody even sees that data in between, they will not make any sense of that, and hence we could have a more secure data transmission. So for uploading, downloading files, website management, data backup, you use this FTP protocol, file transmission or file transfer protocol. Another very good application layer protocol is there, which is known as HTTP, hyper text transmission protocol is the protocol used to transfer web pages from web servers or browser. I have already told you. So, a client sends a HTTP request to a server, just like you send some request from the Google search engine, it goes to the Google server, and Google server searches various web pages for you and transmits back to your computer, pushes back to your computer where you can search, where can you see all these informations which are pushed back to your computer. The server processes the request and sends back an HTTP response containing the requested resource over there. So, it is a stateless protocol, means each HTTP request is independent, no information is retained between requests. Data is transmitted in plain text, make it vulnerable for interception. So, what are the applications where it is used HTTP? HTTP is used for web browsing, API communication and web applications, or even searching of the information. There are certain methods basically. This is the detail of HTTP protocol. It tells you how HTTP protocol works basically. So, HTTP method specifies the desired actions to be performed on the source. So, get command is there. So, get method basically retrieves data from a server. Post submits data to be processed by a server. Put method is there, put method is there, updates or replace data on a server. Similarly, deletes a resource on the delete server. Similarly, head is there which retrieves header of a resource without the body. So, these are some of the you can say methods or commands which are being used in the HTTP protocol. So, that defines how client interact with server in web applications and API. So, you can have an idea using these methods basically they communicate with the servers. HTTPS is the secure version of HTTP protocol. So, HTTPS is a secure version of HTTP protocol that uses SSL and TLS protocols or encryption to protect data during transmissions. So, these uses two technology known as secure socket layer and TLS protocol, TLS methods for encryption method to protect data during the transmission. So, you might have seen in all the bank transactions or important transactions, financial transactions, nowadays we are using HTTPS instead of HTTPS. So, the transmission which is taking place between the client and server remains more secure. It uses SSL or TLS certificate to establish a secure encrypted connection between the client and server, and it ensures data integrity and privacy as well. The benefits of HTTPS are protects against eavesdropping. I have already told you that in between there may be some hackers, we can spy the data. So, from it protects against such eavesdropping, man-in-middle attack and data tampering. It is essential for secure online transactions, particularly banking transactions, financial transactions and confidential transactions. What are the applications? Secure websites, e-commerce, online banking, data sensitive communications, all uses which protocol? HTTPS protocol for data communication or data transfer. Now, coming back to lower layer, from the application layer, now we are coming to which layer? Application layer to transport layer. In transport layer, we do have two protocols. In transport layer, there are two protocols. One is known as TCP, another is known as UDP. So, first you see the TCP protocol. Transmission Control Protocol is a connection-oriented protocol that ensures reliable data transmission between devices. So, there are two types of protocol, UDP and TCP. TCP ensures connection-oriented or supports connection-oriented data transmission, while UDP is known as User Datagram Protocol. It supports connection-less type of application. There are two types of application. Say for example, if I want to send some email to my friend who is residing in some parts of US, say in the California. So, simply I will write down the email using any email client, maybe Gmail, maybe Hotmail, maybe Rediffmail, and I will put the send button. The moment you click the send button, your message is transmitted to the nearest server. From nearest server, using the routing protocol, it goes to the next server, and it in this way basically, by going to various intermediate server, it finally reaches to the destination server. And whenever your friend logs into the system, he finds that okay, I have a mail from my friend, he can simply answer or reply back to your mail, and the mail will be sent back similarly to your computer. It reaches to your computer basically. This type of communication does not require a connection to be established prior to data communication, as it is required in case of mobile communication. Say for example, I am calling a friend. I will not start without dialing the number, without having a connection. I will not start, hello, how are you? I will not. No. The protocol is that first of all you will dial the number. When you dial the number, rings goes over there, and if your friends picks up the phone, then the connection is established. Once the connection is established, then you start talking to him. This is the example of connection oriented. But while writing some message, text message, you simply write the message and send. It is not required to establish a connection prior to sending a message. So this type of application requires UDP protocol. UDP protocol supports this kind of application, connection-less, which requires connection-less. It is just similar to the whenever you write some postcard or message and drops that message in a post office box. From one post office box, it go to head post office. From head post office, it go to another post office, and thereby similarly, which in turn reaches to the destination post office that is delivered to the person. So this is an example of connection-less service. But telephone, whenever you're talking about telephone, before the communication starts, you will have to establish connections between the two communicating parties prior any communication takes place. They are known as connection-oriented services. So TCP supports connection-oriented service and UDP supports connection-less service. Fine. So okay. So what are the, I'm discussing right now TCP. So TCP is a connection-oriented protocol that ensures reliable data transmission between devices. What are the key features? First of all, a connection is established. So prior the communication takes place, a connection is established using three-way handshake protocol between two computers. And error detection and correction. If something goes wrong, there is a mechanism to correct that, detect and correct the errors if something goes wrong while transmitting the data. And flow control manages the rate of data transmission to prevent network congestion. So these are the key features of TCP protocol. What are the use cases? Web browsing, email. So web browsing, email, file transfer, secure data transmissions. These are some of the applications of transport layer protocol, both including connection oriented and connection-less services. What is three-way handshake? Three-way handshake means whenever computer A wants to transmit data to computer B, say for example, which is part of the network, first of all the computer A sends a special signal which is known as sync signal, SYN. It's a special kind of signal. The moment B receives sync, it understands, oh, that okay, A wants to transmit some data. So it replies back by sending the sync with acknowledgement signal. So sync plus AC key is sent back to the A. The moment A receives sync plus ACK signal, it understands that okay, now B is ready for the transmission. So it sends back now the data, starts sending back the data or acknowledgement simply. Now the connection has been established. Now A can transmit the data from one place to, from A to B. Once the data transmission is over, then any of these devices can send FIN signal, FIN, FIN for finish. Sync for start, FIN signal. FIN means just okay, I am done with data transmission, I want to disconnect. In the similar way as after talking to your friend, whenever it is over, you want to terminate the connection by pushing the red button over there. So terminating the connection starts from FIN. So similarly, you send the FIN character. The moment B receives the FIN character means okay, now A has done with the data transmission. B also replies by FIN plus ACK. So this is how the connection is terminated once the data transmission is over. Fine. So this is the three-way handshake and termination of the connection. So all these such kind of things are supported by TCP protocol. These are part of the TCP protocol. TCP ensures the reliable data transmissions. In case of UDP protocol, it may happen that say for example, you are dropping two letters in the same mailbox for the same address. It may happen that one letter reaches over there earlier while the second letter may reach to the destination after some time. It may happen. This happens in the case of network also. Okay, whenever you are sending the packet, because packets are transmitted via several routes. There are alternate routes. So say for example, these are the networks. and this computer wants to send some packet to this thing. Say for example, 3 packets are there. So 2 packets are routed via this way and 1 packet is routed via this way. It may happen that this packet reaches to destination first, while these 2 packets reaches destination last. So it may happen in case of user data protocol, which gives you the facility of what? Connectionless service. Then what will happen basically? What will happen over here? The order of the message will not be maintained. Order of the message is not guaranteed in case of UDP. So if the message is like that and this part reaches first, this part reaches last, so all the order will be intermingled with that and we cannot understand the things over there. So some applications are there which require the ordered transmission of data, and that is ensured by the TCP. So there must be a sequence number for that. So okay, 3, 2, 1 is there sequence, 3, 1, 2 is there. So whenever it reaches over there, there is a mechanism that okay, all the 3 packets are there, then it will be reassembled like that, 1, 2 and 3, and after reassembling it will be given to the desired user so that he or she could understand the message. So that is the sequence number. Each byte of data is assigned a sequence number which ensures correct data order at the receiving end. It may happen that some packets may reach compared to other data, but at the receiving end they are reassembled according to which number? According to sequence number, thereby giving the correct data to that. Similarly, acknowledgement. The receiver sends an acknowledgement for received data confirming successful delivery. I have already told you that here you see whenever you receive some information, sync character is there, they give you the ACK signal, acknowledgement signal over there. This happens in case of TCP. So acknowledgement is received for the data received. If data is lost or corrupted, then the TCP has the provision to tell you that please retransmit the data, because the data earlier you have transmitted has got corrupted or has got lost during the transmission. So it can request you to retransmit that data. This way it is taking care of the lost segment or corrupted segments, thereby ensuring data error corrections methods. Congestion control. Sometime the whole network gets congested. In that case, TCP has the inbuilt mechanism to come out of the congestion situation, and it controls the overall environment by slow start, gradually increase data transmission rate and adjust data flow to prevent network congestion. So all these things are inbuilt with the TCP IP protocol so that it ensures you the better delivery with greater efficiency and reliability. So in that case, you can say that TCP provides reliable communication even over unreliable networks. So unreliable means some data may get lost, but they are taking care. TCP is taking care. Oh, something has got lost. So again, it is asking the sender, please resend the message so that I can correctly reassemble the data and pass on to the desired users. Next to that, lower to that, this transport layer, we do have the IP layer, Internet Protocol layer. So IP is a protocol responsible for addressing and routing data packets to ensure they reach the correct destination. So it ensures you from node to node delivery, from one node to another node delivery. Two types of IP protocols versions are there, IPv version 4 and IPv version 6, and we have told you that IPv version 4 uses 30-bit address for IP address, while IPv version uses 128-bit address. It is designed to overcome some of the IPv4 limitations. What is the functions of IP protocol, Internet Layer Protocol? First is routing. Routing means to determine the best path for the data. In the route, in the network, it may be there are several other alternative paths available in the network. But out of these several paths, which one is the optimal path, which one is the best path, that is decided by the IP, Internet Protocol. So routing is the main function of the IP protocol. And another thing is that fragmentation. I have already told you in my previous lecture, say for example, you have 10 MB message. So 10 MB message or 10 GB message, that big message is not transmitted as a whole to the network. Instead, they are split into various packets, and each smaller packets are sequenced. They are given some sequence numbers, and they are flooded in the network. So whichever path they find suitable, they traverse from that and reaches to the destination. But in this process, it may happen that some of the packets reaches Earlier, the last packet may reach earlier, or the first packet may reach later over there. So no issue. Whenever all the packet reaches the destination node, they are first reassembled according to the sequence number, and the correct message with the correct sequence is delivered to the user at that end, and this is taken care by the TCP, that is known as fragmentation. So break a large packet into smaller fragments transmission, and at the destination end again it is reassembled in the correct order to give the correct message or reliable message to the destination node. What is the importance? Importance is the fundamental of all internet communication. Routing is the main protocol, I mean to say, which moves the data or transmits the data from one place to another place. Another very important protocol is there which is known as ICMP. So ICMP is basically adjunct protocol, means they assist IP protocol in making certain types of decisions or functions, I mean to say. Say for example, IP tries its level best to deliver the message from host to the destination, from host or source to destination, I mean to say, from source to destination. But if something goes wrong due to any reason, due to the network flaw, due to the problem in the network, if the data gets lost, then IP does not guarantee that your message is reaching from source to destination. Then you can say that it is a very alarming situation. Then how? Because after sending the data, I am assured that my data will be reaching to the destination or might have reached to the destination, but in between it has got lost, and IP protocol is not informing me, even not informing me that your data has lost. If they had informed me, I had sent it back to another copy, I had sent it back to the network so that my information reaches to the destination. Yes, this task is being done by ICMP, because IP is the best effort delivery protocol. It tries its level best to deliver the message, but something goes wrong, it does not have any rescue mechanism. So rescue mechanism comes with the form of ICMP, Internet Control Message Protocol. It is used by network devices to send error messages and operational information. If something goes wrong with the packet, it is the user or the whole source is informed that the packet you have sent earlier has got corrupted, please resend it. That is done by whom? That is done by ICMP protocol. So what are the basic functions? Apart from error reporting, it uses tools like ping and traceroute to diagnose the network issue as well. So these are some of the functions of ICMP. And what is the importance? It helps maintain network reliability and troubleshoot problems. And below that, we do have physical Ethernet layer or physical layer protocol. We have the main protocol which is known as Ethernet protocol. So Ethernet protocol is widely used network communication protocol that operates at the data link layer of the OSI model, enabling devices with a local area network LAN to communicate via standardized frames. Here at the data link layer, it is the frame, not the packet, which is flowing across the network. So they handle the frames level. So frames are there in that level, packets are there, and above layer you do have the whole message. So and the TCP level we have the segments basically. So at the data link layer we do have frames. At the IP layer we are dealing with packets. At the TCP layer we are having with segments, and at the application layer the whole message is there. The complete message is there. How Ethernet works? I have already told you that it uses MAC address to uniquely identify devices on the network. So it operates on the MAC level. And at data link level always operates on the MAC. Above that, if you have a network level, then the operation takes place on the basis of IP addresses. But here the operation takes place on the basis of MAC level. They operate on the MAC level. It transmits data in the form of frames containing source and destination address are there. So Ethernet frames are there, and there is always Ethernet frames are like that. We do have source address, destination address, some other informations are also there. So you see here, this is known as Ethernet frame. Source address, destination address, and preamble is there, and like that. We do have certain information in the apart from the data. So it transmits data in the form of Ethernet frames containing source and destination address, header checking information, and payload data. Payload data means actual data is there. Modern Ethernet supports full duplex communication to eliminate collisions. What is the benefit of Ethernet technology? It offers you high speed and reliability for wired networks. So, high speed transmission can be achieved with higher reliability means. That is the reason why Ethernet local area networks are very popular. Scalable from a small home network to enterprise level setups. I have already told you that if you require to add some more computer in the Ethernet, it is very easier to add some more computer, thereby making the whole system more scalable. It supports various standards such as fast Ethernet, Giga Ethernet, and supports 10 gigabit Ethernet. So, nowadays it starts at 10 Gbps or 10 Mbps, 100 Mbps, 1 Gbps, 10 Gbps. Now it supports up to 100 Gbps of speeds of data transmission, I mean to say. So, what are the possible application or basic applications of Ethernet technology? It's connecting computers, printers, and other devices in local area network. It acts as the backbone network for business and data centers and industrial automation systems requiring low latency communication. Where fast communications are required, we use Ethernet LAN. So, today we had a discussion on protocols of various layers of TCP/IP protocol suite, and we have seen the overview of various protocols of the TCP/IP protocol layers. So, with this we finish your discussion on internet technologies, especially the TCP/IP protocol suite, various protocols of TCP/IP protocol suite. Thank you very much.